So, let's see. All right, did you guys do the prep problems?
I didn't.
Okay. Let's see.
They were pretty.
Yeah, let's go over them. I haven't even taken that exam 4 yet because I was gone, and so I'm taking that this weekend. But like, I haven't done the homework for this week, so I don't really know exactly how to do it. Do you know?
All right, so you guys want to open up the preparation materials, all kinds?
Yeah, I have them open.
Claire, do you got them open?
Claire, do you got them?
Got what, the preparation?
Yeah.
Yeah, just.
Yeah, they're.
All right. Yeah, we got them.
Okay, so do you guys know what you're trying to find?
Oh, aren't you just trying to cancel out the variables?
Yeah, but okay, so what you're trying to do is you're trying to find an x value and a y value, or there are multiple values, however many there are, that x minus y equals 7 is the same thing if you plug it in y plus x equals 5.
Okay.
You do that is you have those two equations, you just add them, quote unquote, together. So you'll put x plus y equals 5 on the bottom. So when you add them together, the y's cancel out, and you left 2x equals 12. Then you just divide by 2, x equals 6, plug 6 back in, and then algebraically solve it, and then y equals negative 1.
So explain to me, you cut out the very first part, what you did.
Okay, so what you do, here, I'll kind of hold it up to the camera. So, you guys look on mine. So you just set it up so they kind of equal each other. And the y's will cancel out. And the x's you add together, so you get 2x equals 12. And then you just divide by 2, x equals 6.
So you'd set up as negative y plus x equals 7, and then the y's would cancel out, so then it would be 2x equals 12, so then x equals 6.
Yeah.
And then on that next one, you would want to...
Well, then you got to plug this 6 back into one of the equations to find the y.
Okay, so then it would be 6 minus y equals 7, and then, so y equals 1.
Y equals negative 1.
Negative 1, yeah, okay. Yeah, I got that. Claire, do you understand that?
Yeah.
Okay.
Okay, so the next one's a little bit more complicated. What you essentially have to do is you have to somehow add all of the equations together while you eliminate variables. So what that means is you can start with 3x minus y plus 2z equals 14.
Yeah.
And x plus y minus z equals 0. Just start with those two equations.
Yeah.
And just do, go down the line and just put them together and cancel, so the y's will cancel.
Yes.
And you're left with 4x minus z
plus
z equals
14.
So then here's the really confusing part. So now you gotta put that on the side and hold on to it later. Now you want to take the second equation and put it with the third equation.
Okay.
X plus y minus z equals 0, and 2x minus y plus 3z equals 18.
And then you're going to get rid of your y.
Again, so you're going to be left with 3x plus 2z equals 18. Now you have two equations, and they both now have the y value eliminated, so you can put those together. So you have 4x plus z equals 14, then you have 3x plus 2z equals 18. Now, if you add those together, no variable will cancel.
Yeah.
So you have to multiply something so they cancel it. So you can multiply the 4x plus z equals 14 by -2. And you need to make sure you do that to the other side on the 14 value. So you're left with -8x minus 2z equals -28. And you put them together, you're going to get -5x equals -10 divided by -5.
X equals -2.
2.
2, yeah.
So then what you do is you can plug that into any of the equations. You don't want to plug it into one of the first three. Do it that way, it's just more step.
Yeah.
So you can go back to like 3x plus 2z equals 18. 3 times 2 plus 2z equals 18. 6 plus 2z equals 18. Subtract 6, you get 2z equals 12. Divide by 2. Z equals 6. Get two variables, you just plug the 2 back to the original one. You find out that 2 plus y minus 6 equals 0. The y that makes sense.
Yeah, I got it.
Yeah.
Claire, could you know?
I got it.
All right. So those what you basically want to do is you as many variables as you can, and remember you don't have to add all three together at once. You can break them up into separate equations. Just make sure you keep them the same. So now when you go down, the next one it's kind of similar, right? So you just have three equations.
Yeah.
Basically have to do the same thing, cancel variables, so you find whatever you have to find. And that's what that is.
So what you'll do is you'll take the first two equations, add those together, then you'll take the second two equations and add those together, solutions from both of those equations, and add those together, and then to cancel out a variable, you're going to have to times the numbers by each other so that you can cancel out the next variable, 1, and then you can just plug that back into your 2 that you figured out.
Yeah.
Okay.
Pretty much.
Yeah, I got that.
It's a lot of basic algebra. You just have to know the formula and how to add it, when to add it. So it's really not that difficult.
Yeah, and then as far as like the names of the functions, what are the names of the two functions that we can get?
One is the quadratic, I guess, whatever, because you have an x squared, so it's a parabola.
Oh, yeah.
The other one is just a line. So you basically what you're going to have 2 points. This is what they're saying. Then you're going to have like 2 points like that, and those are the coordinates when you're given like the last equation. And we'll go over those other stuff, but that's the point you have to find.
Okay.
That means when you press it.
Okay.
Any other questions on that?
No. So what are the different methods for solving the system of nonlinear equations? So there's substitution and there's elimination, right?
Are you back on Purple and Joey?
Well, I was just looking at it and it said to discuss number 4. Talking about the different types of equations.
Okay, hold on, let me look for it. Number 4. Where do you see number 4 at?
I'm actually not seeing number 4.
What was your question? So there's elimination, substitution, multiplication, addition, subtraction.
Yeah. So on the GHOA it says question 4 on the prep assignment. Discuss the different methods for solving the system of nonlinear equations.
Oh, okay. Yeah. We'll get to that in a minute. There's what you have to do. It's you have a couple options of what you can do. So my personal, what I like to do when you have nonlinear, which is like all of them, try and sketch a rough.
Yeah.
And you kind of can tell, and then but you can also set them equal to each other. So when you're looking at the GHOA heat there, you see it's y equals 3x with whatever that is.
Yeah.
What's that called? Absolute value. So what does the absolute value graph look like? Sometimes I don't know, right? It's great.
It's a V, yeah.
Yeah, that's it. So what we know about this graph is that since there's no number when x is 0, y is 0, right?
Yeah.
So that your point starting, and then the slope is 3. So whenever you go up 3, you go over 1, up 3 over 1, right? So it's gonna just be a big old V on your paper.
Yeah.
First equation. The next equation, x squared, it's a parabola.
Mm-hmm.
So and it has a +2, so it starts at 2 above the x-axis on the y.
Yeah.
X squared, so when it's 1, it'll be over 1 up 1. When it's 2, it's over 2 up 4, that kind of thing.
Yeah.
So from the point, so then you kind of draw a rough graph, and you're kind of going to get where your points are on the thing, and you kind of can see where it's roughly going to be.
Yeah.
Basically.
Yeah.
Like 1, 3 would work. -1, 3 would work. 2, 6, and -2, 6. I think those are points.
Uh-huh.
And I'm pretty sure the other thing you can do is, so that's one way. The other way to solve it is you set them equal to each other. And what that means is, so the x and y coordinates are going to be the same. So on the bottom value, whatever y equals, it's going to equal the same on the top. So you can set it up that x squared plus 2 value of 3x. Does that make sense?
Mm-hmm.
Fire?
Yeah.
No. So then, you can, since you want to try and get the 0 on one side, you can subtract 3x from both sides, and you're left with x squared minus 3x plus 2 and x squared. Well, that's the value stay or no?
Is what?
The absolute value stay? I don't think it stays.
No.
So then what you do is you just solve it algebraically, so you'll get x minus 1 times x minus 2. Set those both equal to 0. X is going to equal 1 and x is going to equal 2. Plug those in, find the y coordinates, and since it's a parabola and absolute value, use the opposite sign, not just.
Yeah.
Because you're going to get the same answer.
Yeah.
Does that make sense?
Yeah.
Yeah, it does. I got it.
Okay, so the next one is a major pain in the butt. because I don't like this one at all. So what we're trying to do is, since it's not equal to y, you're trying to do what we did in the preparation thing. So you're trying to find stuff that cancels, right? But looking at this paper, nothing cancels. So you have to multiply something or divide something.
Wait, did you just do the extension problem number 1?
Yeah.
Okay, I was looking at the prep problem still, and I was like, what? What are you doing?
No, I'm sorry. I moved over to the extension problem.
Yeah.
Any other questions on the preparation?
No, I'm good, because when you were explaining that first one, I was following along on the prep assignment, and it made sense, so we're good.
Okay. So anyway, yeah, that was the first extension problem in the GHOA. Sorry if I didn't make that.
No, you're totally fine.
Okay. So then, to clarify, the second problem in GHOA.
Yeah.
It's x squared plus y squared equals 25, and you have x squared over 18 plus y squared over 32 equals 1.
Yeah.
So what I'm going to do, and you guys can agree or disagree, I would multiply the bottom by -18.
So that we can get x squared.
Yeah, so you get -x squared on the bottom.
Yeah, that looks good.
So you get the same thing on top, but on the bottom you'll get minus x squared minus 18y squared over 32, which cancels to, I believe it's 1/2.
9/16.
18 divided by 32.
9/16.
Okay, is that what it is? That's
Yeah.
right. So then you're left with 9y squared over 16 equals -18.
Yeah.
So x's cancel out. You can,
Subtract.
y squared at 16 over 16, so you go 16 minus 9. You're left with 7y squared
Equals
-18. Multiply it by 16 over 7, 16 over 7.
times by
288 divided by 7, negative, equals y squared.
yeah. It's gonna be 16y squared equals 18, right?
No, it's 7y squared over 16.
Because we multiplied it by 7?
No, because what you did is you basically took 16y squared over 16y squared minus 9y squared over 16. Subtract the top, so 16 minus 9 is 7 on top.
Oh, okay.
It's the same, so you have 7y squared over 16 -18.
Yeah.
Then I multiplied 16 over 7 by 16 over 7.
Yeah.
That way you're left with y squared equals 288 divided by 7. Negative, sorry.
Yeah.
Then you take the square root of that. And in the end, you're left with I don't think this is, I think there's no solution. Oh, maybe there is a solution. Oh, wow, she's got weird stuff.
She's even got whole numbers.
I know. What did I do wrong?
Well, that she got.
Oh, I know what we did wrong. I know what I did wrong. It's 25 minus 18.
7. Uh-huh.
So then, when you subtract 7 from 16 or whatever, the 7's cancel and you're just left with 16.
Yeah.
So your y is 4 and negative 4. Just like she has it right there.
Yeah. And
So
then
that's what, does that make sense where we screwed up? Where I screwed up? 18 away from 25.
yeah.
So left with 4 and negative 4. You just plug those back into an equation, like plug them back into y, the top one.
Yeah.
So 4 squared is 16. 25 minus 16 is 9. Take the square root of it. It's plus or minus 3. So that's how she got that.
Yeah, that makes sense.
Yeah.
Ready? The break. Okay, so this next one is the one where you kind of set it equal to the.
Yeah. So how do we get stuff out of like the square root or the out of the squared?
I don't know. Negative x, isn't that just x over 9? I don't know if that helps. This is a negative.
I'm confused by this one because you can't really subtract them or add them if we have stuff up in the.
Yeah, I don't. So when you pull the 9 to the negative x out, it turns into x over 9. Is that right?
I don't think so.
No. So it's just, I guess, it goes on bottom. Where's the x go? Because like if you have 2, so 9 to the negative whatever, x has to go on top.
Yeah. But I don't know if we can just switch it into x over 9 though.
You're right. Yeah, that makes sense.
I have no clue.
Yeah, I don't know how to do this one.
Should I just email her about this one?
Yeah.
Unless Claire, you got any insight?
Well, I was thinking if maybe we could make them the same base, but I don't really know how to do that.
I don't even know what that means, so yeah, I mean, if you're right.
So change the bases and like make the top one have a base of 9, like the bottom one.
Yeah. Or like, I don't know, like, I feel like we did something. I just forgot what it was.
Or do like 9 to the 1/3.
Yeah, maybe.
I'll just email her about this one.
Okay, because the other one, the last one,
Yeah.
One's pretty simple.
Yeah.
And she basically did the work for us.
Okay, so number 2 is a little bit more difficult because it involves fractions with the variable in the denominator. It's been started to discuss the method being used and why it's a good method, then finish the problem.
Well, I would obviously multiply it by -2 on top, or I guess you could multiply it by -3 on the bottom. Doesn't matter what you choose.
I would say we multiply the top one by -2.
That's what she did. I mean, it doesn't matter which one you do. You just have to do it.
Yeah, so let's just multiply by -2. So it'll be -4 over x plus 6 over y equals 2. Or -1, sorry.
So pretty much then what you do, so once you get to the last part where you have -5y over or equals -1/3, I mean, you can, if it's, I mean, to me, it's pretty easy to tell that y equals 15 because, you know, you're trying to get to equal -1/3. But you could add 1/3 to the other side to make it look better. And then that way you're trying to find 1/3 minus what equals 0. So you're trying to find 1/3 minus 1/3 equals 0.
So did you get 7 over y equals 1/3? Or did you get 7 over y equals -1/3?
No.
What'd you get?
-5y. -5 over y equals -1/3.
How'd you get negative on that? Oh, because we by negative. Okay, yeah. -5y. -5 over y equals -1/3.
Right.
And so obviously y is going to be 15.
Yeah. And then you can just plug that back in, you know, and get 1/15. Then you subtract 1/15 on both sides.
So it would be like 5. It'd be like 10. So 4 over x equals 11/15.
Equals what's 1/2 minus 1/15 times that by 5. 10/15, you'll get 9/15. So 4 over x equals 9/15.
Yeah.
Then multiply that by 4 at the top by 1. Multiply by 1/4. Multiply that by 1/4. And do believe.
So where did you go from here that 4 over x equals 9/15?
Say that one more time.
Where did you go after you got the 4 over x equals 9/15?
I multiplied the side by 1/4, just 1/4, both sides by 1/4. Then you're left with 1 over x equals 9/15 times 1/4, which is something. Which is
9/60?
3/20.
Yeah.
So then you just, you know, flip them. So then you have to multiply the other side because it's still 1 over x. So you have to multiply the other side by 1, or basically you just have to flip the sides.
So it's going to be x over 1 equals 20/3.
Equals 20 over, yeah. So x equals 20 over 3, actually, yeah.
Yeah. Wait, so what we did there is we just did problems 2, 3, and 4.
Yeah.
Nice.
Okay.
That's why I said it's pretty easy usually.
Yeah.
I just don't understand the third one and how we're supposed to like put them together. Maybe that one's the only one where you have to draw a graph. That can't be the answer. I don't know.
So we're supposed to find maybe the arch problem. What's that mean?
Not discuss solution. Maybe the arc problem. I don't know what that means. I think we did it.
Well, yeah, we finished the problem because the answer is 20/3, like we said, and 15 from up top.
Beans.
So finish the problem and discuss the solution. So I guess maybe she wants us to go back up and plug it into the original equation and see if it works.
I mean, you can. I will. So.
So 2 divided by 20/3 is 1/3. So 1/3, or so it'll be 3/10 plus 3/15, which equals
Yeah. I mean, it's.
yeah, and it comes out as 15/30 or 1/2.
Yeah.
Yeah. All right. Well, is that it then?
Yeah, that would be it for the week.
Okay. And then she said that we could do those hangouts from that week that I was gone. Do we want to meet tomorrow and do the group quiz?
You guys for sure can, but I have to work.
What time do you start?
5 or 4.
And then in the morning?
Yeah,
And then you get out at what time?
probably like 5.
Okay. Would y'all be able to do like 6?
I mean, I could. I'm just saying, I know our time is set up for 12 to 5, so
Yeah.
if it has to be that because of months.
Claire, can you do 6 tomorrow just to do the group quiz from that week that we missed?
Yeah, I should be able to.
Okay. So do we want to plan on tomorrow night at 6? We'll just get that quiz taken out so we can do it?
Yeah.
Cool. All right. Well, we'll plan on that, and then we'll plan on Thursday just doing a regular time.
Yep.
Okay.
All right.
All right. We'll see you.